The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Getting a Quotient Involving Zero at the End of the Quotient. In the example 4263 divided by 21, we got 0 in the middle of the quotient. Let us take up an example where we get 0 at the end of the quotient, and let us see how to identify that from the result area. Let us take the example 7366 divided by 32. Let us set the dividend in the right side of the abacus, that is 7 in the thousands column, 3 in the hundreds column, 6 in the tens column, and 6 in the units column. Let us set the divisor 32 at the extreme left of the abacus. As the highest digit of the divisor 3 is less than the highest digit of the dividend 7, we have to set the quotient by skipping a column to the left of the number 7. Let us begin the division process now. Let us ask how many 3's in 7? There are 2, and by applying the quotient rule, let us reduce 1 and take 1 as the assumed quotient and set it in the 100,000 column. 1 multiplied by 3 is 03, that is 0 is subtracted from the 10,000s column and 3 subtracted from the thousands column. That is, clear 5 in the upper abacus and add 2 in the lower abacus. In the next stage, we have to subtract 2, which is nothing but 1 multiplied by 2 from 43, that is 0 from 4 and 2 from 3. Let us check the numbers now. We have 41, which is larger than the divisor 32, indicating that we have chosen the assumed quotient, which is less than the actual quotient. Simply add 1 to the quotient and subtract 32 from 41, that is 3 is subtracted from 4 and we have to subtract 2 from 1. As we can't subtract 2 from 1, we subtract 1 in the thousands column and add 8 in the hundreds column. Now we are left with 966 in the dividend. Now ask how many 3's in 9? By saying 3, let us reduce 1 and set the assumed quotient 2 to the right side of the 2. As 3 is less than 9, we have to skip a column in setting the quotient. Now 2 and 3 should be multiplied, that is 6, which is 06, which should be subtracted from the thousands column and the hundreds column. Now 2 multiplied by 2, which is 04, that means 0 is subtracted from the hundreds column and 4 subtracted from the tens column. Now we are left with 32. As the first 2 digits of the dividend are same as the divisor, simply add 1 to the quotient and subtract 32. Now we have only 6 left in the dividend and the divisor is 32, and therefore you can't divide. 6 becomes the remainder. Let us look at the result area. You have 6 on the right extreme of the abacus and 3 empty columns to its left, and then 2 digits of the quotient 23. The child should not be tempted to say that the quotient is 23. The columns are to be checked before writing down the quotient and the remainder. As the divisor is a double digit number, the last 2 columns are meant for the remainder, irrespective of whether the actual remainder is a single digit number or 2 digit numbers. The column to the left of the remainder is a separating column of the quotient and the remainder. To the left of the separating column, there is an empty column. That means the value is 0. That is, the 0 at the end of the quotient is a part of the quotient, and therefore the result we get in this problem is 230 as the quotient and 6 as the remainder. Clear concept of the result area is absolutely necessary in order to decode the correct results. Additional care is necessary, especially when there are empty columns in the middle of the result area. Let us do some more exercises similar to this in the forthcoming videos.